Next step in the process is the completion of the tailstock. I've done just about every detail on this tailstock with the exception of the taper in the spindle and the locking components and features. Now, as far as the features are concerned for locking this thing down, I'll share with you the print here. 1/32 slot, 3/8 long. That is the only thing that they give you, except for the thread on the bottom half and a clearance hole on the top half, which is what this all translates to. So basically what they're looking for you to do is pinch this like a clamp as not to damage the spindle. Well, I'm not a big fan of running a slitting saw through this little casting because it's really clean. So I'm going to take some creative liberty right here, and there are several ways to approach pinching this spindle without damaging the spindle. And I'm going to drop in a slug, believe it or not, in that little area right there, probably 1/8 of an inch in diameter or somewhere thereabouts. And I'll split that slug so that when the slug is in position, bottom half tap, top half not, the slug itself will do all the moving and pinch the shaft while the outside of the casting stays complete. That is one option. The other option is to tap halfway through, counterbore halfway through, drop the slug in the top, and let the handle pull the slug down against the spindle. That is certainly the easier option because that is only two moving parts, the handle and the top plug, as opposed to a split plug. So I think that's what I'm going to do. Put this in the fixture, drill it, tap it all the way through, clearance, counterbore it for a seated slug, and then I will make a little slug and the handle. And this handle, I'm going to have to be very delicate with that. I will not bend that handle until I know exactly where everything is going to seat. And then I'm going to bend it so that when it's torqued, the handle is away, which is the way I like my machines, and I try to adjust all my real machines the same way if possible. All right, I will take you and show you the fixture, and we'll get on the machine and make this happen. This is the fixture that I use to machine the tailstock and the headstock. This is a very handy little thing to have. So this area right here is where all the detail work is going to go. And you can see they've given you sufficient real estate there to work with. So I'm very pleased about that. I could put a relatively good sized slug in there. This is a gauge pin for picking up when I come across with the edge finder. It's going to pick up on the side of that, and regardless, or not regardless, but allowing for whatever size screw you're going to use, make sure that it doesn't hit the spindle on the way through. It's got to clear, so that's really important. And as soon as I put this in the machine, I'll put the drill chuck in there, put a couple of gauge pins in, and see exactly what I have to work with, and I'll bring you along for the ride. This shouldn't take all that long. The plug that I plan to put in the top here to secure the spindle is going to go basically in the location of this piece of brass. This is also the same size as the spindle, so some overlap needs to be present, as you can see from this angle right here. It's the only way that that plug is going to trap the spindle. The thickness of the casting right here is a good minimum length of thread that you're going to need on the handle. So we're going to start there, going to make a couple of sketches and knock the handle out first. The calculation for the offset is extremely easy. 0.86 is the major diameter I'm going to use to calculate the size of the screw, and 188 is the spindle bore. So you'll need half of the spindle bore, half of the screw, and whatever gap you want to put in there. I'm putting 5 thousandths in there. So 43, which is half of 86, plus the 5, plus 94, gives me a 142 offset, center to center. With the part positioned in the machine, tram either side of the pin to pick up your 0, and move this way, at least 142. Double check the setup by putting a pin in your drill chuck the size of the screw. Make sure everything clears. Give it however much clearance you want. Using a little bit larger pin in your drill chuck at this time. visually center that pin on that boss to where you like it. Now you're going to be able to see how much wall thickness you have between the diameter that you select for the locking plug and the out part of that casting. Pick a size that suits your available real estate and go with it. I'm going to lock everything down right here, and I'm going to put that 256 threaded hole in. I do expect to have half a hole break through on the bottom. That is perfectly okay, so long as the threaded hole does not intersect with this diameter. And if you look real close, you can see the half hole under the bottom I was referring to. That is not going to be a problem. Set the height of the end mill to be tangent with the gauge pin or piece of material you currently have in the spindle bore. Zero out the table and make sure that cutter comes down at least half the distance of that spindle. On location with the tapped hole, of course. Zero everything out, come down half the pin. If all went well, there is an overlap between the counter bore that you just put in and the main bore itself. We're going to take a look inside here, make sure that some of that wall is gone, and then we're going to make a small washer to drop in there, and when the clamp screw comes down and squeezes it, that washer is going to pinch the spindle, and that will act as the lock. No split necessary. Split it if you have to, but this was my choice. Let's inspect it and make a washer. All right, I think you can see the advantage to not bending the handle yet. And that is exactly what you want to see down inside the spindle, down inside the bore. You definitely want to see the wall breaking through. That means that you've calculated all your numbers right and things will end well. The only thing on the inside of this that's doing any work at all, this is really small, there is a little washer right there. And that is relatively easy to calculate when you have your material sticking out of the lathe. Just put your part on it and look for any type of interference on the inside. I think you can see that. Little knot right there. That does all the work, and that is just so much prettier than a split in my opinion. So let's give it the test. Call that the spindle. Washer goes in the hole. Handle goes in the hole. Zoom out on that seat. Legit. Let's unloosen the handle. There you go. That is a functional spindle lock. Out it comes. Now with it torqued down, I know where I want my position of my handle when I'm working, so I will bend it about 30 degrees towards the rear and bend it over at about a 45 to 60 degree angle. And I'm going to do that off camera because if it breaks, I'm going to cry, and I don't want to cry on film. Anyway, there you go. That is my change to the design. I did not split the casting as suggested on the print. I think that is just as easy what I just did. And it all worked out well. I do appreciate you watching. Thank you very much. Joe Pyatt, Advanced Innovations in Austin, Texas. I'm out.